things, maybe some things that are new ideas, some things that are the industry is already using, but is not completely aware of the consequences of using that. So
Like
just to
AI, like AI, right?
let me pick up an example that is a bit older, because now we can give a distance to analyze. So when the microservices became a hype,
Hmm.
right? Uh, um, so many people sell this idea as the solution to all problems. This is the architecture everyone needs to be using. And then, okay, then people start doing research on that, and maybe some of the initial promises, it was shown that was not like that, or some costs that nobody talked about start to appearing on this kind of research. So then it's like that many companies, and we see, I think like microservices is a good example, because we see many companies that step back, right, and move to the monolith or a different solution, and because they adopted a solution that they didn't know all the consequences of making that decision, right? So uh, um, and this one we can step back, and when we think about the hype that it was and what we know right now, right? We saw that, okay, maybe we didn't have a lot of maturity regarding these things when all these movements started. Um, and about AI, I think yes. For now, AI is obviously is everywhere, even in the research world. I was looking, for example, to a workshop about green software, and there are many papers related to LLMs and AI. So it's everywhere, both for applying AI in software engineering, and developing systems with AI agents. So then both things are a bit separate, because one focus more on the application, the other on the software, the creation of the software itself. But yeah, both are being studied, and for example, what are the consequences of this uh, um, of using AI. So then, as researchers, we try to understand, even propose new ideas that to see if they work, to see what are the consequences, and do that in a more systematic and structured way.
Yeah, I
Yeah.
think this is an important thing that I want to ask is about how this research are executed, because uh, we are not like used to think about research in the scientific structured way. So how do we do this kind of research that you're saying in this structured and scientific way? It's something that we can say, oh no, it's scientific proved that something, because people like to use this word, but we don't know exactly how it works. Can you explain a little bit for us?
Yeah, in the end, let's say software engineering is kind of hard. I remember there was once a discussion. So I hear someone say, "Oh, there was this huge discussion that it's really hard to validate and do prove things in software engineering." And the conclusion was that yeah, it is hard. So there's not much we can do. But in the end, what we try to do is to get evidence. So it's hard to say that, oh, this maybe in some very specific case, yes, but in some cases, like, okay, using this kind of stuff improve developer productivity. So um, yeah, so what we can do is to get evidence that regarding this, and maybe when we're trying to get this evidence, we can find out some interesting things. But proof is really hard because, okay, maybe I can do an experiment where I compare people using with people not using, but okay, maybe different people would be different. Maybe I can experiment this in a large project, but usually when I do in a large project, I cannot have a control group like doing the same project without it. So then we always have some kind of trade-off, right? So for example, when we increase the complexity and the size of the case study, usually we can do just a few. When we have more large-scale experiments and research, we can have, let's say, more, but then it's usually something more simple to be able to scale. And then it's interesting to see that sometimes it's hard to know, but then we get some evidence here, some evidence there. One of the sources of evidence we usually get is, for example, evaluate with professionals or ask professionals to give their opinion. But in the end, okay, if I ask 20 experienced professionals about something and they say, oh, this is great, but it's still their opinion. So it is evidence, it is valid, but proof, it's really hard. So what I try to do in my research is to try to get evidence from different perspectives, different angles, to try to enrich the vision we can think or study about some kind of technique or practice and whatever.
So the idea, like getting like surveys with a huge number of people, so we can get some more statistically.
Yeah. So then this will be a more, let's say, quantitative study, but we can also interview and be more deep with a lower number of professionals. So this one will be more qualitative, and then we will try to get some insights about that. So then usually we try to mix stuff and to get these evidence from different perspectives. So maybe we can get more simple information from a lot of people and more in-deep information, but a small number of people. And then, okay, try to triangulate the findings.
Yeah.
And
interesting.
One thing from our audience here. Unfortunately, I think it's Andres.
It's Andres, right?
Yeah.
Hi, Andres.
Hey guys. Even in physics, we need evidence to prove that the universe behaves as the math say.
Yeah.
Sure.
Exactly.
And then he
the problem is that in physics you can be more precise, right? It's easier to measure.
You can see it. You just see it happening, right?
Yeah.
As I said, for example,